This is Bob Capetta from the College of the Florida Keys, and this lesson is an introduction to series. So we will take a look at this notation. If I have the sum as k goes from 1 to 10 of k over k plus 2. What does that mean? Well, we can make a table and see what we get. If k is 1, what is k over k plus 2? That would be 1 over 1 plus 2, which is 1/3. If k is 2, what do we get? We get k over k plus 2, so 2 over 2 plus 2, which is 2 over 4. I'm going to choose not to reduce that fraction. If k is 3, I get 3 over 3 plus 2. We get 3 over 5. If k is 4, I get 4 over 4 plus 2, which is 4 over 6, etc. Now this notation means add all them up until we get to 10. When we get to 10, that would be 10 over 10 plus 2, which is 10 over 12. So I would actually have to write all these out. 1/3 plus 2/4 plus 3/5 plus 4/6. Hopefully we can see the pattern. Plus 5/7 plus 6/8 plus 7/9 plus 8/10 plus 9/11 plus 10/12. Now we could add all those up and we could find out what that number is. That's going to be difficult to do. 1/3 plus 2/4 plus 3/5 plus 4/6 plus 5/7 plus 6/8 plus 7/9 plus 8/10 plus 9/11 plus 10/12, and I get a very nasty looking number, approximately 6.79358. But that's what it means. It means list out the first 10 numbers and then add all of them up. Now, oftentimes we're interested in the sum of the first n units. So, for example, I might ask for what is the sum as k goes from 1 to n of 2 to the k. So what would that equal? Again, we can make our table to get a feel for what this looks like. We have k and we have 2 to the k. If k is 1, 2 to the 1 is 2. If k is 2, 2 to the 2 is 4. If k is 3, 2 to the 3 is 8. But actually what I have here, fine, 2 plus 4 plus 8 plus 16 plus ... When does it end? It ends at 2 to the n, or maybe you would feel better writing it as 2 to the first plus 2 to the second plus 2 to the third plus 2 to the fourth plus ... plus 2 to the n. That is the sum, I like to use an S, of the first n terms of that series. That's one for us to look at. So we want to make sure that we can do these kinds of things. So, again, not that difficult for us to do. We just go ahead and grab our calculators and add them together. Let's do one more, this sort of a brute force strategy. What's the sum as k goes from 1 to 5 of k squared plus 3k plus 2? So what I need to do is I need to make a table. K. I need to find out what is k squared plus 3k plus 2, and I need values for 1, 2, 3, 4, and 5. K is 1, 1 squared plus 3 times 1 plus 2. K is 2, 2 squared plus 3 times 2 plus 2. K is 3, 3 squared plus 3 times 3 plus 2. K is 4, 4 squared plus 3 times 4 plus 2. K is 5, 5 squared plus 3 times 5 plus 2. And let's find out what all these things are. So if I plug in 1 plus 3 plus 2, 3, 4, 5, 6. If I plug in 2, 6 and 4 is 10, and 2 is 12. If I plug in 3, 9 and 9 is 18, plus 2 is 20. If I plug in 4, 16 and 12 is 28, and 2 is 30. And if I plug in 5, 25 and 15 is 40, plus 2 is 42. So now I've got to add those. That summation notation means add all of them together. So we'll take 6 plus 12 plus 20 plus 30 plus 42 and grab the calculator and see what that gives us. 6 plus 12 plus 20 plus 30 plus 42, and we get a sum of exactly 110. Now I want to make sure we can actually reverse this process. If I give you a bunch of numbers, can you determine what the series in sigma notation would be? So for example, if I have 1 squared plus 2 squared plus 3 squared plus 4 squared plus dot 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 plus 86 squared plus 87 squared. We want to figure out some way for us to discuss this. And what's changing are the bases. So that's going to be k. And each of the bases is raised to the second power. So we're going to look at the sum of k squared. Where does k start? Where does k end? K starts at 1, and where does it end? It ends at 87. So that would be a way for us to express that. What if I had 1 plus 3 plus 5 plus 7 plus 9 plus 11? Well, that's a little trickier for us to do. I need to figure out some way to describe odd numbers. I want to start at 1. In this course, we like our series to start at 1. If we look at 2k, 2 times 1 is 2. How do I get to 1? Let's subtract 1. Is that good enough? 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. How many do I go? 1, 2, 3, 4, 5, 6. K goes from 1 to 6 of 2k minus 1. And let's try 1 or 2 more. Let's take a look at 1 minus a third plus a ninth minus a 27th plus 1 over 81. So sum, we want k to start at 1. And what's happening here? Is there a way for us to express what's happening? Well, it goes positive, negative, positive, negative, positive, negative. One way for us to do that is to take negative 1 to the k, negative 1 to the 1. It would start out negative, but this has got to start out positive. So I'll take negative 1 to the k plus 1. That should do it for me, right? K is 1, 1 plus 1 is 2, negative 1 to the 2 is positive, then negative, then positive, then negative. And then I need 1/3 because each time I multiply by a third, but it starts at 1/3 to the 0, so that'll be k minus 1. And I realize this is challenging. How far does k go? 1, 2, 3, 4, 5. K goes from 1 to 5 of negative 1 to the k plus 1 times 1/3 to the k minus 1. So being comfortable with this is important. Maybe take a look at one more. 1/2 plus 2/3 plus 3/4 plus 4/5 plus dot 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 plus 137 over 138. So yeah, like I was about to say, being comfortable with sigma notation is very important. It's something that we use in calculus quite a bit. What's changing? The top is changing and the bottom is changing. The top starts at 1 and ends at 137, so let's call that k. K starts at 1 and ends at 137. Well, what's the bottom? The bottom is always 1 more than the top. So if the top is k, the bottom would be k plus 1. So that thing would become, the sum as k goes from 1 to 137 of k over k plus 1. So that will conclude this lesson talking about series and an introduction to that sigma notation.